In this video, we're going to continue our work with finding equations of lines, but we're going to find equations of lines that are parallel to a given line. So one of the things that we need to realize, and you probably know it instinctively, but maybe you haven't thought about it, is that lines that are parallel will have the same slope. They're going to lean the same way, aren't they? Because that's why they're parallel. So we're going to use the fact that we know that two lines are parallel to find the missing line, the one that we're asked to find. Let's just work with an example so that I can show you what I mean. Okay, so example 1 here says, find the equation of a line parallel to the given line and containing the given point. Right, in slope-intercept form. So we want our final equation, our final answer to be in slope-intercept form. So the given line in number 1 is the line y equals 4x plus 2. And we want a line parallel to that given line, but that goes through the point 1, 2. Now, first of all, just so that I know that you understand what's happening here, is the point 1, 2, is that point in this line? So how would we check that? Well, you know, we would substitute, right? So 2, does that equal 4 times 1 plus 2? And it sure doesn't, does it? Because we get 2 equals 6, which is not true. So our point 1, 2 is not in the original line, y equals 4x plus 2. Okay. We are going to use the fact that we know that our line containing the point 1, 2 has to be parallel to the given line to find the slope. So y equals 4x plus 2 is our given line. Okay, what's its slope? Well, notice that this given line is in slope-intercept form, so we can read the slope right off of the coefficient of the x value. So we know that the slope is 4 of our given line. But then that means that the parallel line, the one we're trying to find, that also has slope 4. So we're going to use the slope of 4, and now we're going to use the one point that we're given that's on our line, which is 1, 2. So what method do we use to find the equation of a line if we know the slope and one point? If you said point slope form, that is a good strategy. So let's remind ourselves. Matter of fact, let's label x1, y1 here, and then our point slope form, which is y minus y1 equals mx minus x1. So now we'll substitute in y minus 2 equals 4x minus 1. Now, if you haven't had a chance to watch the video on point slope form and you're a little confused by this step that we're doing right now, I recommend you go back and find our video on using the point slope form to find equations of lines. Okay, so we're going to continue though, because simplifying, we got to continue simplifying here because they asked our answer to be in slope-intercept form. Okay, so we'll distribute 4x minus 4 and then we'll add 2 to both sides. And so now we get y equals 4x minus 2. And we're going to check this with a graph. I just want you to see that these two lines, the original line, which was given by y equals 4x plus 2, and our line, y equals 4x minus 2, I want you to actually see that they are parallel. Okay, so let's look at that. Okay, so the given line was y equals 4x plus 2, and we're checking that our line, y equals 4x minus 2, that those two really are parallel. So we're going to use the slope and the y-intercept to draw each of these lines, okay? Let's call this one the red line. The y-intercept is 2, so I'm going to start at 0, 2. I've got here a scale of 1 I'm using for this coordinate system. And so my rise over run, my m, is 4 over 1, so I'm going to go up 4 and over 1. Up 4 and over 1. So there's my first, this is the given line, right? This is the line that was given to us. Okay, so there it is. Okay, now we're going to graph the line that we got in our answer, and we'll graph that one blue. And our y-intercept is negative 2 down here. And we're going to go up 4, because our slope's the same, isn't it? 4 up 4 over 1. So we're going to go up 4 and over 1. Up 4 and over 1. And then we'll draw the line. And do you see how these two lines really are parallel? Their slopes are the same, makes them parallel. They will never intersect. And so I wanted to check this first one so you can see that this really works. Okay, let's do a couple of more examples on finding equations of parallel lines. Okay, example number 2, we have our given line is y equals negative 3x minus 1, and our given point is the point 2, negative 3. Looking at our given line, we see that that's in slope-intercept form, so we can read the slope right off of the coefficient of x. So Rm is negative 3, and then our point for the new line, the one that we're trying to find, is 2, negative 3, and we're going to label those as x1 and y1. And then we're going to use our point slope form again to get their equation. And so that goes as y minus y1, which would be a negative 3, equals m times x minus x1. And then we're going to distribute the negative 3, change these two signs here to y plus 3 equals negative 3x plus 6. And then we're going to subtract 3 to get this line into our slope-intercept form, which is right there. Okay, I bet that one went a lot quicker for you. Okay, now what happens if our given line starts out in standard form? Let's take a look at that one of those. Okay, so for problem number 3, our given line is in standard form. So we have to first rewrite this line in slope-intercept form so that we can determine the slope. So we're going to subtract, see, I'm going to put negative y equals negative 2x plus 6. I'm subtracting the 2x over, and then I'm going to divide by negative 1 because my y is negative. I need my y to be positive in slope-intercept form. My coefficient to be a 1y. So there it is, and then 2x minus 6. Okay, so now our slope here is 2. So we're going to use m equals to 2. And then our point, of course, negative 3, 0 will be our x1, y1. And we're going to substitute into our point slope form. So y minus 0 equals 2 times x minus a negative 3. And so now let's go ahead and distribute here to get this into slope-intercept form. And it was kind of nice that that y minus 0 was there because I made it easy. 2x plus 6. And so now I have here my final answer, y equals 2x plus 6. For problem number 4, we once again have a given line in standard form. We want to find the line that goes through the point negative 10, 7 and is parallel to our given line. I'm going to let you pause the video now. I'm going to ask you to pause the video and give this a try using number 3, the work that we just completed, as your guide, and see how far you can get on finding this equation. Now, when you unpause the video, you will see my solution, and then you can compare. So pause your video now. So the first step was to rewrite the given line in slope-intercept form so that we could get that slope of negative 4/5. And then we used our point slope form using x1, y1 with our given point negative 10, 7. And then after we distributed and solved for y, we arrived at this answer, y equals negative 4/5 x minus 1, which is the parallel line in slope-intercept form. How did you do with that? Okay, in the next 2 examples, we're going to talk about those special lines, horizontal and vertical lines. Let's take a look at those next. So in problem number 5, we have the given line is x equals negative 4, and we're looking for the line that's parallel to that given line, and that goes through the point negative 3, negative 5. And of course, do you recognize the x equals negative 4 as our vertical line through negative 4? I thought it would be good to have a visual, so I went ahead and put this little grid here. And if we go here to negative 4, then our given line is this line that is vertical, x equals negative 4. Then let's look and see where is our order pair. Well, it's at negative 3, negative 5, so let's give that a shot here. Negative 3, negative 5 is down here and next to that arrow, okay? And if we were going to draw a graph that's parallel to the vertical line, but that is shifted over to where this point is, wouldn't we have to draw another vertical line? What do you think? So wouldn't the parallel line have to go through this line, this point, and just be right next to that other line? Yeah, so it's another vertical line, isn't it? So vertical line would have a parallel line that's also a vertical line. So we just need to find the equation of the vertical line that goes through this point -3, -5. And as you look at that drawing here of that black line, all of these x-coordinates are the same, and they have the equation x equals -3. So this parallel line being another vertical line that goes through the point -3, -5, so the equation has to be x equals a number, and all those x's on that line are -3. Okay, one more to do here, which is our horizontal line. So this time around we have the horizontal line y equals 9 as our given line, and our point is -8, 6. So let's draw the horizontal line. Let's think that this is a 9, and so y equals 9 will be this horizontal line. Goes through 0, 9. And then our point -8, 6 would be over here, like it would be like right there, -8, 6. And we would have to draw another parallel line, and we would have to draw a horizontal line to make it parallel to the given horizontal line. So now this line that's in red that goes through our given point, -8, 6, what equation does that have? Well, the y-coordinate of every single point that's on that line going through our point share a y-coordinate of 6. So that's the equation of the parallel line, parallel to y equals 9. Go to the next video so that you can learn about how do we find equations of lines when we're looking for equations of lines that are perpendicular to each other.